You're listening to Strange by Nature, your guide to the strange, weird, unbelievable, and improbable wonders of the natural world.
Hello, everyone. Thanks for being here today. I am Kirk Mona, and I am joined today by Rachel Ginza and Victoria Thompson. We are all professional naturalists who together have scoured the world for weird and wonderful wonders just to please your mammalian brain's desire for novelty. Isn't that nice? Let's do this.
Well, everybody, welcome. It is a slightly special episode. It's episode 50.
Yay!
A meaningless number chosen. I mean,
it's halfway to 100.
Our slavish
also a
medevotion to
meaningless
base
number.
10.
Yeah. Just
No.
think if we only had 8 fingers, on our hands instead of 10, would 50 be a big? Would that even be a thing?
I mean,
No.
depending who you talk
Probably
to, technically we do have 8 fingers.
Do not get me started on the thumb.
No.
Do not.
That's why I said depend who you talk to.
Ridiculous.
So,
But anyway,
All right.
we're not really doing anything special for episode 50. We have something planned for when we've been on the air for a year, which will be a few episodes from now. So stay tuned, but this is just going to be a regular episode.
If you guys want to make it special, the listeners could go to patreon.com/strangebynature and become patrons. That would be a special gift to us on 50 episodes. If you're enjoying what you're hearing and want to support it, we would love that.
And if there's a certain number of dollars that matches up with that you feel like... No.
Wow, 50,000 is kind of a lot, Victoria. I don't know what you're asking them to do. They're like 50 cents done. No, we do appreciate everyone who listens, and thanks for being along for the ride and coming with us on this journey thus far. We got a whole lot more to do.
yeah,
I think, Victoria, you're starting us off this week with
something.
more goods.
I am starting us off this week. And I want to start out with a question for you two.
Ooh, I love
Tell me what you know about bees.
I know a lot about bees. What kind
I
of
know
bees?
you know a lot about bees.
You
did
want
an
me to
episode
tell you
about
what I
bees.
know about bees?
Just like the highlights of bees. What do they do?
What
How many
kind of
hours do you
bees?
have?
So, like, just
These are members
like-
of the order Hymenoptera.
Yeah.
Do
Or
you-
maybe the better way to phrase this is what do you
Honeybees?
think
Solitary
most
bees?
people would say about bees?
They're yellow and black and they sting you.
yes.
Okay.
They
What
make
else?
honey,
And they make honey.
They make honey. Do they do anything important?
pollinate. They're
they
pollinators,
Uh-huh.
things like
Yeah.
that.
Yeah.
By the way, the making honey thing, I understand. It's honeybee propaganda. I appreciate that. But at the same time, most bees do not make honey.
Is that where you're going with this?
Yes.
Not exactly.
Okay.
Oh.
All of what you said is true. I am going to tell you, though, about a type of bee that does things a little differently. Here is a hint.
Is it?
Okay.
Do you
Not a
remember my
wasp.
topic from last week
Yes.
about the carnivorous plant?
Yes, it's a carnivorous plant.
Scientists were...
You talking about a carnivorous bee?
Yes.
Okay.
All right.
I am taking
So
this
it's not
story
a
to the
wasp.
bee world. It's vulture bees.
What?
Oh my gosh.
I've never
All
heard
right,
of vulture
I'm ready,
bees.
I'm
I'm
in.
ready. I'm here. I'm ready. I'm wearing yellow. I'm so ready.
I knew you would be into this, Rachel.
I love bees.
Yes, you do. Vulture bees, they belong to 3 or possibly 4 species of social bees in the genus Trigona, and all of them are found in South America. They are part of a much larger group of stingless bees. And like other bees, they do drink nectar and sweet fruit juice and like plant stem juices and things like that. But whereas most bees get their protein from pollen,
Right.
vulture bees exclusively eat meat for their protein.
Yes.
What? Wait, when you
Yes.
say meat, what kind of meat? They're vulture. Are we?
talking
Wait.
steak
Whoa! They're
or-
vulture bees. Are they carrion
dead?
eaters?
As their name suggests, they like rotting flesh.
Yes.
Yes. This is
What a
amazing.
valuable ecological service bees do for us. Add one more to the list.
I
Indeed.
love bees. This is so cool because, like, not only are they like pollinating, but half the time by accident, like helping make food, or not even make food for us. That's not how that works. But like helping the that's a offset. Actually, I'm not gonna get into it. I will talk about it all day.
Yeah, these are
Please
actually
go on.
non-pollinating bees because they don't visit flowers for nectar. They get like fruit juice, they tap plant stems and stuff like that.
Okay,
But
bees in general do that. But like vulture
yes.
bees now also eat dead things. This is so cool.
Absolutely.
I don't know if you're gonna get through this without Rachel just completely losing her mind. But try. Do your best.
Do our best. So they completely lack the pollen carrying structures that most bees have.
Okay.
So they are completely reliant on meat. And these type of bees have been known to Western science for a couple of centuries, but their flesh foraging behavior was only observed by scientists about 40 years ago. So relatively recently.
Flesh foraging.
Yes.
What
Possible episode title. Okay, go on.
foraging.
So interestingly, they also do produce honey. Like a lot of the stingless bees produce honey from
Does
the
it taste
nectar
like
they
meat?
eat. I have not tried any.
Rotting meat. It's from the nectar, but I gotta imagine it's in a stomach.
Well, I mean, how
potentially with
honey.
rotting flesh.
One
Word.
source I said it had a kind of intense, spicy sort of flavor. So make of that what you will.
Okay.
That might just be from the plants that they're gathering
Yeah.
the nectar from.
Well,
Okay.
but it bodes the question: do they have separate stomachs? Because generally speaking, if they make honey, they have like a honey type stomach they.
Right. Yeah. That's right.
Yeah,
So-
I did. That question did pass through my mind. I didn't dig far enough to be able to find out the answer to that. But I'm going to touch on the stomach issue if you'll
Excellent.
Okay.
bear
Keep
with
going.
me. Yeah.
Touch away.
Thanks.
Okay.
You're welcome.
So what they do is they visit a carcass and they often enter through the eyes, much like maggots do. Good
Gross.
entry
Yeah,
point.
yeah.
Yeah.
Pretty standard.
And they have big teeth on their mandibles that they use to scrape off the
What?
flesh.
Like true
And-
teeth?
Do not like.
No, not true teeth, but like serrations, you know.
Okay.
Okay.
Yeah.
Not like buck teeth, like
No.
a beaver's. That'd be weird.
They can also defend their carcasses from other insects, such as flies and ants that want to use it.
Huh.
And they can bite people, for example, even though they are stingless. So they do defend themselves.
Oh, by biting. Cool. Okay.
Yeah, biting bees. There are
Sweet.
a couple of competing hypotheses about how the bees process the meat. So one is that they carry actual pieces of the meat back to their hive and then mix them with honey and keep them in a special storage pot for a couple of weeks to mature. Then they
Probably some enzymes breaking stuff down in there as well. Then.
undoubtedly,
Proteins
and then they
going
would
through.
feed the mixture to the larvae. Because they live, when I said social bees before, that means they live in a hive and have a queen and all that kind of stuff,
Yes.
which not all bees do. The other hypothesis is that they use some kind of enzyme, like in their saliva, to partially dissolve the flesh before they swallow it, and then carry it back in a special stomach and regurgitate it into the same little storage pots that I mentioned before.
So they have found the storage pots.
Yes, and these
Okay.
pots
So the
are
debate
kept.
is just whether they're bringing it back with like mouth enzymes or not. Is that
Yeah.
kind of the-
Yes, as far as I can tell.
I'm
So
really simplifying here, but
yeah, basically. So these little pots are kept separate in the hive from the honey. So the honey is theoretically not tainted by the rotten meat, and it can be collected and eaten by humans, although it's not terribly abundant compared to like honeybees.
Yeah.
Not. Why would you want to though?
oh! The honey can be collected.
The
I thought you were
honeybee.
saying the rotted meat can
No.
be collected. And I'm going, no.
mean, You could,
no,
I guess.
Victoria. Why?
The honey.
Yes.
The honey.
Okay, the honey.
Good clarification. Thank you. Thank you.
So the reason I even heard about vulture bees, because I had not heard of them before, was I saw a news item about a paper that was recently published that looked at vulture bees' microbiomes. and compared them to other closely related bees that live in the same area.
Okay.
Yeah. So this paper is called "Why Did the Bee Eat the Chicken? Symbiont Gain, Loss, and Retention in the Vulture Bee Microbiome."
That is.
It's
Can
by,
you explain for
and-
listeners who don't know what a microbiome is?
Yes.
And just what that is real quick.
yes. So basically, your body, a bee's body, any animal's body, has trillions of bacteria and other microorganisms, viruses, fungi that live in it and have a symbiotic relationship. So like you've probably heard about your gut bacteria. Your gut bacteria is part of your microbiome. And bees have a microbiome in their gut also. So what these researchers were doing, led by Laura Figueroa of the University of Massachusetts at Amherst, they captured these bees by setting out bait traps of chicken.
By the way, what an excellent scientific article title. It's beautiful.
Absolutely. That's why.
So good.
I can already smell it. Go on.
Yeah, rotten chicken is special.
Oh.
So they set out these traps and then they would capture the different kinds of bees, including the vulture bees, and analyze their gut bacteria. And I guess they did DNA analysis to figure out what it was. And they got some really interesting results. So first of all, the guts of the vulture bees are highly acidic due to so our stomachs are acidic because we make hydrochloric acid from cells in our body, but bees are acidic because they have bacteria called lactobacillus, which create lactic acid. And lactobacillus also is the same genus of bacteria that people use to make things like yogurt and sauerkraut.
Right, I was saying that sounds very familiar.
Okay.
Yeah. The other bees, non-vulture bees, did not have lactobacillic or acidic guts. And all the non-carnivorous bees all pretty much had the same few species of symbiotic bacteria in their guts. But the vulture bees had a couple of those, but then a whole bunch of other bacteria, which were very similar to those found in other types of carrion eaters, like vultures and hyenas.
Okay.
So even though they're like completely different areas of the animal kingdom, they wind up having pretty similar environments in their stomachs and guts.
That's
the
so
question
cool.
that comes to my mind immediately is, are those bacteria also found naturally, like on the skin of animals or in the flesh of animals, so that the animals that eating let's say chicken flesh, naturally pick those up as a way to help digest it because they're already on that? That would explain how they got them, but
I think that may be part of it. I'm not totally certain on that point.
Does it have to be
research topic?
Oh yeah. Huh.
But at any rate, these symbiotic bacteria let the bees eat the rotting flesh without getting sick the way that you or I would. And it's also what lets hyenas and vultures and animals like that do it.
I will avoid the raw chicken, thank you.
Yeah, no, thank you.
Fair enough.
So that's most of what I have to say, except that just to wrap things up, an interesting point that the authors made in their paper was that bees can actually be considered vegetarian wasps. So
really,
bees
I was
evolved
wondering
from
if
wasps.
these are wasps. Oh.
Wait. Say that again. Bees?
Bees evolved from wasps.
Okay.
So bees could be considered wasps that adapted to an herbivorous diet.
So kind of like how all squares are rectangles, but not all rectangles are squares.
Right.
Yeah.
So this is basically like some bees who've gone back to their old wasp-like ways.
Exactly. Vulture bees have kind of gone back to the roots in some way of considering it.
Interesting.
Huh.
Yeah.
Or
that's so cool.
They never leave.
That's so cool. Like, oh my gosh, my brain. Bees are amazing, and they don't get enough credit, and they do. But most people only think about the honeybees. But there are so many other kinds of bees.
Oh yeah.
Yes, there are.
So many. A great topic for another day.
Yes. Thank you,
All right.
Victoria.
You're welcome. When we come back from the break, we'll have Kirk with something fresh. Hopefully.
Could be rotten and ready to be eaten by bees.
Gross.
Kirk here with a quick note. If you're enjoying the show, be sure to subscribe and leave a 5-star review. It helps other lovers of the strange find our show. You can also find and follow us on social media. Search for Strange by Nature Podcast on Facebook, Twitter, and Instagram, or come visit us at strangebynaturepodcast.com. We'll see you there. Now, back to the show.
This week, I'm headed back to Indonesia because when I talked about Krakatoa several episodes ago, I mentioned that it wasn't actually the biggest eruption in recorded history.
Mm-hmm.
So
Might have been the loudest. You're talking
that
about
is my topic for today.
Oh,
We're talking about the big one.
what? I don't know what the big one is, but I'm
What's the big one?
excited.
Well, we're gonna find out. So, the volcano eruption in question we're talking about is, in all fairness, not probably the largest volcano ever to have erupted. So, Victoria, you mentioned supervolcanoes a number of episodes back, and Yellowstone is the example most people are familiar with, and I think you talked about as well. And these supervolcanoes have erupted in the past, but almost all of them predate human beings even existing.
Right,
It was like
right.
millions and millions of years ago.
We are but a blip.
There's only been one, what I would call sort of a modern supervolcano, which was in New Zealand, and that was around 27,000 years ago. And so, while there certainly were humans around at the time, there's not really any like surviving, like even an oral tradition or anything of that eruption. So, while there have been eruptions larger than the one I'm going to talk about today, we only know about them from like what they left behind. And I want to talk about one that was actually witnessed and recorded in more sort of modern times. So as Victoria pointed out, a supervolcano was given a rating of 8 on the VEI scale. That's the Volcanic Explosivity Index. And as a quick refresher, the scale is logarithmic, meaning every increase in the number is actually 10 times more explosive. So 8 is as high as the scale goes. Krakatoa, which I talked about before, which was just amazingly destructive and super explosive, it was only ranked as a VE6, or what's sometimes called a colossal explosion. Today, we're going to talk about a super colossal eruption that ranked a VEI 7.
Oh,
So,
no.
You
Wow.
already know, if you're paying attention, that what I'm about to talk about is 10 times more explosive than Krakatoa.
Oh, no.
That's
Oh, yeah.
a lot of explosiveness.
That is true. This week, I'm talking about the eruption of Mount Tambora.
Oh, I have heard
Have
of
you
Mount
ever heard of
Tambora.
that?
Yes.
Okay,
No.
so Mount Tambora is located on the island of Sumbawa in Indonesia. For those not familiar with Indonesia and the area, if you can picture Australia, just north of Australia, there's like a thin line of islands, and that marks sort of the start of Indonesia there. Sumbawa is one of those islands.
Okay.
This is also the same region that Victoria talked about when she did a story about Wallace's line back just 10 episodes ago in episode 40. Go check it out if you haven't heard that. So Krakatoa is also part of that same chain of islands. So we're talking about a fairly geologically active area, to be clear. In fact,
Sounds
some
like it, yeah.
scientists have said if we're going to have another one of these major eruptions, it's going to be in Indonesia. So
Yeah.
Okay.
keep that in mind.
Makes sense.
So both these volcanoes are fueled by the same subduction zone. Now, back in 1812, the long dormant Mount Tambora began to awaken.
Sorry, what year did you
So-
say?
1812. is when we're
1812.
talking about.
Okay.
I
so
thought
this
you
was-
said 1910, and I was confused.
That would be wrong. 1812. So this was before Krakatoa, and Mount Tambora had certainly erupted in the past. I mean, in fact, it's a stratovolcano, meaning it's like a cone-shaped mountain that is built up by many stratified layers from multiple eruptions. So
Okay.
clearly there had been lots of eruptions there before. The previous eruptions had built the mountain up to reach 14,100 feet tall. Now that's
That's fine.
that's big.
Yeah.
It was the biggest mountain in all of Indonesia, and it's not ridiculously huge. There's certainly higher mountains in the world, but when you stop to think of it, this is a 14,000-foot high pile of debris from previous eruptions.
Yeah.
Okay, now it starts to feel like this
Yeah.
isn't just a mountain that was pushed up because of, plate tectonics. This is a 14,000-foot high pile of debris from previous eruptions. So pretty impressive. For reference, this is about 500 feet taller than Mauna Loa on Hawaii. So we're talking pretty good sized.
Okay.
Yeah.
Although Mauna Loa from sea level.
No. Thanks for bringing that up. The Mauna Loa from sea level,
Okay.
not from the ocean floor, which that's a whole nother.
That's another episode.
Too.
Yeah.
Now, all those eruptions that built up the volcano had also drained the magma chamber that lies beneath and that was feeding the eruption. So it took centuries to very slowly refill. And so for as long as people could remember, the mountain had been fairly quiet. And from what I could gather, it wasn't just that the magma chamber was refilling that caused the enormous explosion that was to come. The magma that had remained had been cooling for centuries and essentially created like a pressure cooker type situation as it started to sort of stratify and different like types of rock were starting to separate out in that cooling magma, and it kind of sealed stuff up and started the pressure cooking.
Oh no.
And in 1812, clouds began to appear around the volcano, signaling that it was awakening. Now, that's not when the big explosion and eruption happened. That's just when the volcano, people started to note that it was coming back.
Okay.
So 3 years after those first recorded signs, the volcano awakening, a major eruption began on April 5th, 1815. Explosions could be heard as far away as 780 miles, which was in Java.
Okay.
And that was during this initial phase. Not as far as Krakatoa was heard, but 780 miles is a really long ways away. So those must have been some
That's
really major
still really loud.
explosions. Yeah. And we don't have any firsthand accounts from the island, but we do know that ash began to fall on the 6th of April in East Java, which remember is 780 miles away.
Yeah.
So something massive was going on already. Rumbles and explosions like thunder could be heard for the next 4 days. And on April 10th, things really started to intensify. Detonations like the sound of cannon fire could be heard 1,600 miles away now in Sumatra.
Wow.
And there were reports now from closer in of what was happening. The volcano was erupting from 3 separate spots on the volcano. And as the day went on, those merged into one massive column of ash and fire, reaching 44 kilometers in height. For those of you not using the metric system, that is 27 miles high into the sky. That's 10 times the height of the mountain itself. So
yeah, wow,
really high.
Oh no.
Yeah. Now here's the problem when that happens. You have this giant column going up in the air. Eventually, it can collapse and start coming back down. And it formed a pyroclastic flow. And a pyroclastic flow is a mix of ash, pumice, boulders, and toxic and extremely hot volcanic gases that travel along the ground at speeds up to 430 miles an hour.
No.
Which,
completely devastating.
Yeah, and keep in mind, it's also like over 1,000 degrees centigrade, so about 1,800 Fahrenheit. Sometimes they can move slower, like maybe 60 miles or so, but this was miles an hour. This was going like 430 miles an hour is how fast they can go. Utter devastation at that point.
Gone.
Yeah, pyroclastic flows are considered one of the most deadly parts of a volcanic eruption.
Yes.
It spread down all sides of the volcano, and it wiped out at this point the village of Tambora. So the flows reached, we know, 12 miles away from the volcano. And the eruption continued for days and days and days. The cloud of ash created pitch darkness during the middle of the day, 370 miles away.
Wow.
So they reported that it was pitch dark for 2 solid days.
Whoa.
When this eruption was going on.
That's
when
nuts.
all was said and done, the mountain had been reduced in height from that 14,100 feet to 9,354 feet, having lost 4,700 feet in height.
Oh my
And,
God.
It's a lot of rock.
Yeah,
Just
some calculations
gone.
have shown that there's actually magma coming up from out of the earth. This volcano converted 150 gigatons of magma into ash, pumice, and other ejecta.
Oh, wow.
That's not a number that has any meaning to me because it's so large that it doesn't really mean anything.
Yeah.
Oh my.
So the energy release was equivalent to 33 billion tons of TNT. I made the comparison to the little boy atomic blast last time, so I'll do that again. That is equivalent to 2.2 million atomic bombs going off.
Absolutely not.
Holy-
That's
No, thank you.
Yeah. This
That's
was
insane.
This was big. So not surprisingly, there was quite a death toll. Most
Yeah.
estimates put the death toll around 70,000 people, but some numbers are much higher than that. Some are lower. It's understandably a little hard to say. Also, what do you count in that? And people who died just because their village got wiped out, or are you talking about people who died from tsunamis? People who died from just the
ash.
toxic conditions, the ash and whatnot. One of the interesting effects of this eruption is that it plunged the Earth into what's called a volcanic winter.
Yeah.
In much of the northern hemisphere, where there was a lot of writing about this, there was essentially no summer in the year 1816. There are multiple records of snow falling in June in North America, which is just and just destroying crops, not being enough light for crops to grow, and it being cold. This was a time of Lord Byron, and so he actually wrote a poem called Darkness, and the poem says, "I had a dream, which was not at all a dream. The bright sun was extinguished, and the stars did wander darkling in the eternal space, rayless and pathless, and the icy earth swung blind and blackening in the moonless air. Morn came and went and came and brought no day." And this is thought to be in reference to this year when basically there was just so much ash in the atmosphere that it was like the sun didn't come out and they didn't have summer. There were crop failures around the world, which led to famine and death. So it is really impossible to know how many people around the world actually, starved due to crop failure, or there was this was during the Napoleonic Wars, and so it's like there was that actually fueled some of the Napoleonic Wars. I mean,
War of
it's
1812.
it's impossible to really put an actual number to the disease and death that was caused by this eruption, and some other ones that happened right around the same time. But the number is likely astronomically far above that 70,000 number. So personally, I hope we never see a VE7 or VEI7 eruption in our lifetime. As exciting as it would be to study that in modern times,
Right.
the
Let's not.
aftermath is not good.
No.
So I'm going to say no thank you.
We have enough problems already.
We do
Just a little
indeed, even though it might cool the Earth slightly, which we could use these days.
But I don't think that's how we
not
want
the way
it
we want
to go.
No.
Yeah.
No.
So that is the story of Mount Tambora, and the largest ever eruption in recorded human history.
I mean,
Thank you.
Thanks.
Yeah, right?
We talk about how
more you know.
nature is strange, and how we've talked also about just the different ingenuity and the strength of humans in different ways. Like you talked about the atomic bomb, and like that for modern human history, that it's very much like it was a devastating thing to happen. And
Right. And we see that as like the ultimate destructive thing.
exactly, and then you compare
it's
it's nothing, and that's just
Yeah.
the planet doing its thing.
Yeah,
Insane.
makes you feel kind of small.
Oh, crazy. Thanks.
Well, everyone can ponder that for just a moment, and
I'm gonna need to.
yeah, and we come back. Rachel, compose yourself because you're up next.
Okie doke. All right, everyone. Welcome back. As I talked about last week, I'm doing my first ever two-parter, and you
That's
all
right,
know
yes.
what I am
Yeah.
talking about this week.
We've already talked about turtles breathing through their butts.
Exactly. Now we're going to
Anaerobic
talk about
respiration. Woo.
anaerobic respiration, which
All
is
right.
a little bit different. So we talked last week about cloacal respiration and how that works. But a big problem, which we also talked about, is what can happen when everything in the pond or the lake is using that dissolved oxygen.
Mm-hmm.
But the pond is frozen, so there's not any new oxygen coming in because there is a layer of ice. So the dissolved oxygen level slowly dwindles to nothing.
And
What
that's
do
when
turtles
you can get
do?
like winter fish kills and things like that too.
Yes.
Exactly. So some turtles have actually found a way around it.
Amazing.
Like snapping and painted turtles, which are pretty common around where we are. They can't do it for very long. Like they can do anaerobic respiration for about 100 days, and after that it
Okay,
becomes
that's pretty long.
That's
now.
pretty
It's
long.
decently long, but if they go over that, it becomes extraordinarily dangerous for them. And
Okay.
we're going to talk about it.
So
So,
it's like an end of the winter strategy here.
yes, very much. So, to when I talk about respiration, I'm not just talking about like breathing in and out. I am talking about like cellular respiration levels, where they are utilizing, they're creating energy by using the dissolved oxygen in the water and exchanging it and going through some chemical processes in their cells and in their body to create energy so they can do tasks. It's something our bodies as endotherms do all of the time.
Using
Anaerobic,
glucose.
using glucose. But oxygen is generally a very important part of that process and is necessary in order to do it.
Yes.
Right.
Anaerobic respiration is a way for animals to go through and create the energy and still be using that glucose, but they're not using oxygen. That's why it's called anaerobic.
Which is wild.
Yeah.
Yeah.
It's
Tell us about it.
crazy. So when you are using oxygen, electrons of your cells and of the process itself are shuffled along an electron transport chain, and the final acceptor, the electron acceptor, is oxygen. Okay? It's molecular oxygen is super high energy. It's the oxidizing agent, and it's just a great electron acceptor.
That's why we use it.
Is why we
Mhm.
use it. In anaerobic respiration, what happens is they use either nitrate, so NO3, or they use sulfate or sulfur as electronics acceptors at the very end. So this just ends up meaning that they go through the respiration process, and as they go through that respiration process to create ATP from ADP, which are the energy molecules that our body uses in our metabolism, it produces the energy, but they end up with they end up with something that they don't necessarily want, which is lactic
Okay.
acid.
Yes.
Okay.
Okay. I was going to ask what the trade-off was here.
The trade-off is they end up with a buildup of lactic acid.
Yes.
So if
Okay.
anyone is curious, if you do a really good like workout, or if you rock climb and your muscles get really sore afterwards, it's because especially if you didn't stretch, it's because your muscles are have a buildup of lactic acid, which makes you feel like you have a cramp, your muscles are tensing up. So when turtles use this process and they do it for too long, pretty much when they come out and they're able to start respirating normally, they have to, if they come out of it, they can't just use dissolved oxygen. They need to be able to actually use their lungs
Mhm.
because they're one big old muscle cramp, pretty much.
Yeah.
That sounds
Which
awful.
sounds terrible. So it's super important when it comes to being able to survive the winters. Generally speaking, if you're in a wetland or whatever, the turtles will be using some sulfur as well, just because that's what's there as an electronic acceptor. Um, it causes them to be able to obviously survive. But another drawback to this particular method of being able to survive and be able to have energy to continue on, they also turtles skeletons and their shells will actually create a carbonate buffer to help neutralize the lactic acid buildup.
Oh, wow.
So it's not as deadly, but that also means their shells and their skeletons just end up just a little bit thinner. It's not as
Sure.
strong.
You're converting some of that calcium in the shells and the bones into that buffer.
Just so that way they're not getting a ton of buildup of that lactic acid. Because if they get a lot of it, it ends up, it can kill them.
Yeah.
It strikes me there's so many different methods animals use to survive the winter.
Mm-hmm.
They're all amazing, and they're all also so risky.
They're very risky.
Yes.
Like, if those turtles do not bask in the sunlight and start increasing their metabolic rate, that's why it's so important those early days of spring when you see all those turtles out and about on like rocks and sunning themselves and getting that, and they're increasing their metabolic rate, and by doing so they're able to rid their body of that lactic acid and all of the acidic byproducts of their anaerobic respiration that they had to use towards the end of winter, which is nuts. I was reading this really interesting paper. It was in the Journal of Physiology. It's called Hibernating Without Oxygen: Physiological Adaptations of the Painted Turtle. The author is Donald C. Jackson. It was published in 2002. And it was really interesting to read because it really goes in depth about the metabolic conditions of the painted and compared to like endotherms like us, and the differences and what happens when turtles, specifically painted turtles, start using anaerobic respiration. One thing that I thought was amazing is we talked about it a little bit, or I feel like I talked about it, is that their metabolism goes down in the winter because as it goes down, it has to go down because they're not getting enough energy, enough heat to be able to use their normal processes. But it's central to their ability to tolerate low oxygen levels in lakes and ponds and things. And to give you a little bit of a number for it, as compared to a mammal of similar size of like a painted turtle, so say like a muskrat. Okay.
Sure.
An ectothermic painted turtle, its energy metabolism is only 10 or 20% of like a muskrat.
Yeah.
Which is
That's not much. I mean,
like,
when you don't have to keep your body that warm.
Right.
Yeah.
Well,
you
this
spend
is
a bunch of energy,
this is at the same body temperature. When they're at the same temperature, their energy metabolism is only 10 to 20%. And at lower temperatures, it's crazy. And as the temperature drops, the turtle's metabolism will continue to fall.
Even lower.
Wait, are we talking
lower
about body temperature, or are we talking about external temperature?
Well,
because the muskrat's going to be at the same
It's
body
the
temperature
same
all the
thing.
time.
That's true. I'm talking about the painted turtle. So like a reptile. So it would be the internal temperature for the most part, but it generally correlates with the outside temperature.
Sure, for a painted turtle, but not for a muskrat.
Yes.
Yeah.
Not for muskrat. Muskrat is just there for comparison's sake.
Okay.
Because its temperature doesn't change.
It's so fascinating, these different adaptations, because, people and mammals and other animals can do anaerobic respiration too in their cells, but for very short periods of time. Like, you might use it if you're sprinting. You kind of alluded to that, Rachel, with the muscle cramping that you mentioned. But yeah, for the turtles, it's a months-long survival strategy.
100 days.
It's nuts.
Brutal.
But yeah, I just wanted to touch on that and finish up about anaerobic respiration and how turtles use it. It's crazy. It's super dangerous, but it's a way for them to get through. So
awesome.
Yeah, that's what I have for you this week.
Thanks for bringing us on this journey.
Anytime. Thank you all for joining us this week.
See you next week.
It.
Bye-bye.
Bye.
Thanks everyone for listening to today's show. Be sure to subscribe. New episodes drop every Wednesday, and we love sharing this strange world with all of our listeners. If you would be so kind as to leave us a 5-star review, that would be great. It lets other lovers of the strange discover the show. You can reach out to us on social media by searching for Strange by Nature Podcast on Twitter, Facebook, and Instagram. You can send us an email as well. Our address is contact@strangebynaturepodcast.com. If you want more information about the show, you can also check out our website, which is strangebynaturepodcast.com. Until next week, get outside, stay curious, and embrace the strange.